Okay, as we study refraction, let's look at how a ray of light refracts through a rectangular glass slab. Right? So I have drawn a rectangular glass slab PQRS over here, and a ray of light AB is incident on one side at point B. Since this ray is traveling from rarer to denser medium, it will bend towards the normal and travel across BC. Right? And then when it is incident on this interface, it is traveling from denser to rarer medium, and therefore it will bend away from the normal and travels along CD. This is how the ray travels in a rectangular glass slab. The angles that we are looking at is here, we call this angle I1, right, which is the first angle of incidence, and this is R1, right, this angle is R1, right? And so the angles are I1, then we have angle R1 over here. Then on this second interface you have the second angle of incidence, which we notify as I2, and this angle is R2. Now earlier we have already shown that angle I1 and angle R2 are equal. Angle I1 is equal to R2 and R1 is equal to R1 is equal to I2. So this is how, based on geometry, can be proved, and based on the Snell's law of refraction, we can prove that these two angles are equal. In this video, what I'll be focusing on is trying to understand lateral displacement. So first of all, let us try to understand what exactly we mean by lateral displacement. Lateral, the word lateral means sideways. So what is the sideways displacement here? In this case, the ray AB, if the glass would not have been there, would have traveled without deviation, something like this. This is the path of ray AB if the glass slab would not have been there. But actually the ray has come out along CD. So this particular, the shortest distance over here, this distance is known as the lateral displacement. This is the distance by which the ray has got laterally displaced. It would have traveled like this in this direction, but has got displaced like this because of the glass slab. And this perpendicular distance between these two rays, shortest distance, is known as lateral displacement. And the objective over here is to get an idea about how do we find out lateral displacement and on what factor does it depend. Okay, so I want to find out lateral displacement. What I'll do is I'll show the lateral displacement over here. So from point C, I'll drop a perpendicular on this particular line over here. So I'll draw a line over here. This angle is 90 degree, and I'll make this a thick line over here. Okay, yeah. So, and let us give a name to this point. That is called this point T. Right? So we have now the lateral displacement, and our object is to find out an equation for CT. Right? So if I focus my attention on triangle BCT, for example, let us look at triangle BCT. So triangle BCT. Now this particular angle, I know this angle is R1. This angle is R1. I'm interested in this particular angle. Now, this entire angle, this would be equal to I1, because the I1 and this would be vertically opposite angles. You can see this line over here. This is the normal. So this would be I1. So this angle would be I1 minus R1. We can call this angle as delta, right? And what we can show is this angle delta is equal to I1 minus R1. Okay. So if I focus my attention on triangle BCT, sine delta is equal to opposite side, that is CT upon hypotenuse, which is BC. And I'm interested in finding out the value of CT. So I get CT is equal to BC into sine delta. So this is BC into sine of I1 minus R1. Okay. Now I want to find out an expression for BC. So for that purpose, I focus my attention on triangle BC. Let us call this point as M dash, right? Just for sake of simplicity, instead of this point M dash. So I am focusing my attention on this triangle. Triangle BC M dash. And in this I have this angle R1. So if I take cos of R1, Cos we know is adjacent side upon hypotenuse. This is the hypotenuse. This would be the adjacent side, BM dash. This is the opposite side. This would be so this will be BM dash, and hypotenuse would be BC. Therefore, BC is equal to BM dash into cos R1. Now, what is BM dash? BM dash, I can call it small t as the thickness of the glass slab. Right? This distance is the thickness of the glass slab. So I can show this as T into cos R1, where T is thickness of the glass slab. So T cos R1 BC. Let us call this equation 1. Let us call this equation 2. Now putting the value of BC from here into this equation, I'll get CT is equal to BC is equal to cos R1 is equal to BM. So BC is equal to, I think I've made an error over here. Let me take this part out. Cos R1. Therefore, what I'll get is BC is equal to, not an error, but I think I should have arranged it slightly differently. BC is equal to BM dash upon cos R1, because I want to substitute BC over here. Okay, so putting this value of BC over here, which I should write as T upon cos R1, so CT, which is the lateral displacement, will be equal to BC. BC is T upon cos R1 into sine of I1 minus R1, and therefore lateral displacement is equal to T into sine of I1 minus R1 upon cos R1. So I get this equation for lateral displacement, and as you can see over here, if I know the thickness of the glass slab, I'm aware of the thickness of the glass slab, so T is known to us, right? If I know the angle of incidence, I can find out R1 from the formula mu is equal to sine of I upon sine of R. So if I know I and if I know T, I can find out R1. I'll get all this quantity, and I will be able to find out lateral displacement. So this is how we get an equation for lateral displacement, and if we simply know the thickness of the glass slab and the angle of incidence, we will be able to get a good idea about the magnitude of lateral displacement. And this also explains to us that lateral displacement depends upon the thickness of the glass slab. It depends upon the value of refractive index, and because I and R1, this relationship would be obtained by the refractive index of the glass. How much is the reflection happening? And that's common sense, because if the refractive index is high, this will bend more, and if this bends more, it will move away from this line, and therefore lateral displacement will be more. Right. In another video, I will look at lateral displacement in detail and look at all the factors on which lateral displacement depends upon. In this, we have just looked on two factors based on this particular formulas, but there are other factors on which lateral displacement depends, which we'll see in another video. Thank you.